All right guys, welcome back to the shop. This is gonna be part 5 of our big Puukko project. We have our billet mostly drawn out. Look how big that is. I got my shop helper, and is that heavy?
Yeah.
A little heavy? Oh, you're strong. And we have to clean this forging up a little bit and then start putting the pattern into this billet. First thing we're gonna do is get the forge lit. I'm gonna use a little forge today here, I think, and test out my forge doors a little bit here. All right, while that's heating up, I want to show you guys something here. So these are the combination dies on the little giant here that I put on recently, and I've been using them, and they're pretty good. I've had to tighten the bolts up a couple of times on the top die, and I've had to tighten this shim a little bit on the top die, but they've stayed put really well otherwise. However, you'll notice that these corners are very hard corners and the edges are very hard 90-degree edges. So this is flat, this is dead flat, and that's good. That's good, but the edges are so crisp that they're not so forgiving, which could be a problem for a variety of reasons. Now, holding it flat is one thing, but if you have a piece of steel that has any difference or deviation in the thickness or the angle, it's not quite as forgiving as you're feeding it into here. So this bar, for example, it needs thinned down, but there's no graduation between whatever you're forging it here to the next thickness, if that makes sense. It just cuts a 90-degree, forges a 90-degree corner right there as you're feeding it in, which can give you little creases in your forging. So all that to say, I'm going to pull these off. We're going to soften these corners a little bit and then put them back on. Once you get that bolt, hand it to me and I'll clean it off and we'll put it up so we don't lose it. All right, you see what I've done there? Nothing too crazy, just kind of feathering that in a little bit so that as we're using these dies, it's not just a harsh 90-degree, so it gives a little bit of a little more forgiving as you're feeding stock in. It can kind of, you know, gradually, if ever so slightly, forge that to the dimension that the main part of the die is at, instead of just a sharp 90-degree corner right there. So I think that'll be a lot better. Yeah, just do it with your, no, that's fine. Okay, there they are, all rounded up pretty nicely, and they're about 2 inches longer than when we cut them in half, or they cut that first piece in half. And this is yeah, they're about 1 inch 15/16 to 1 inch bars here. So that's pretty hefty. Honestly, I would probably draw them out even more, but I don't want to. So we're just gonna go with it like that. So let's talk about the pattern and why I'm actually gonna cut them in half again. Okay, so let's talk about the pattern, because we are now finally to the point where we can actually put the pattern in. It's a lot of forging, it's a lot of work, but we're finally there. So the pattern that we're gonna do, and a number of you guys guessed it correctly on the last video. I said leave a comment with what you think the pattern is gonna be, and a lot of you are right. It's gonna be a twist pattern, and I'm gonna explain why. So the twist pattern is a pretty classic pattern welded Damascus steel pattern, and it involves literally taking the, well, you're gonna see how it's gonna be made, but the reason I'm choosing that is because the twist pattern is relatively simple to do at this point. At this stage, we're not gonna go into anything like mosaic or some super involved pattern. That's beyond the scope of this project. That's not what we're trying to do here. We're gonna make some really cool, very useful blades here, knives here, but there's a very practical reason for using the twist pattern as well, and I want to explain that because it's kind of a geeky part here. So as you know, the steel that are in this billet here is the 52-100 steel and the 15N20. Stacked up, we're up to a little over 200 layers, or right around 200 layers. And what the twist pattern does, probably more effectively than most patterns, at least most simple patterns, is when you take that and you twist that enough, if you just do a little spiral, this isn't going to be so much the case, but if you put a good twist in it, which is what we're going to do here, and then you forge that flat, what ends up happening is when you twist that all the way around enough that you're going to actually orient the sides of the billet here in a perpendicular manner to the bar, okay? And so you forge that out flat, and you actually have your layers running well, not completely perpendicular, sort of at an angle usually, but perpendicular to the bar. The reason that is relevant in any way for a practical use standpoint is what that does is it takes and distributes those layers of steel in a even manner across that blade. And so to whatever degree that our 15N20 has less edge retention or less abrasion resistance than the 52-100, which it does because it has less carbon in it, to whatever degree that is the case, we're going to actually orient those layers of steel in such a manner that it will almost be like having a series of teeth. And I want to be careful saying that because the 15N20 is not just going to disappear and leave the 52-100 to do the cutting. However, instead of having all the layers sandwiched like this and you're down to, what's the edge actually down to? Maybe 1 or 2 layers depending on what is wandering in and out of that actual very edge. And that's not terrible, but I'm saying we're going to actually employ that 52-100 all the way along the edge, all the way along the blade in a much more effective fashion than simply having the layers laid next to each other, and then whatever layers are actually down at the edge, that's what you have for your edge. As you know, there is a metallurgical difference between the 52-100 steel and the 15N20 to the point where the 52-100 steel is going to hold an edge better. Now, I already mentioned a couple videos ago that there is not a disparity in the heat treat, that they can both be heat treated properly together. I'm not going to go into that again, but nevertheless, that 52-100 steel is going to hold an edge a little bit better. So it makes sense that we have these, what's the word, laid out equally throughout the blade so that we get the best cutting performance across the edge that we possibly can. Now, this isn't really by design. The reason we're using 15N20 is because that's kind of what's available. I am not aware of any other nickel content steel that has the carbon content close to 52-100. And so that's what we have to use if we want to make a pattern welded steel blade, and that's what we're using. So, but we can make it the best blade we possibly can, and this is one way to do it. So that's a very long explanation. Let's twist some steel. It's amazing how much work is represented right here. It off. No. That is a workout. 25 twists, full twists per bar. A little shorter now. All right. All right, there, that's 2 of 4 bars, and you can see the lines running pretty much perpendicular to the bar here. Nice tight twist. One of the reasons we have to twist it so many times to get such a tight twist is as we forge it lengthwise, it's going to stretch that out and kind of de-emphasize that tight twist, which will be fine, but that's why you have to plan ahead for that. So at this point, we have to grind the surfaces. You can see, maybe, maybe not, some very, little minor surface. They look like cracks or little inclusions that just happen when you do a twist pattern. Unavoidable, but they're just surface level, and we'll just grind those off, get rid of those before we continue forging. So we don't want those in our steel going forward. And then, of course, the very ends here are not twisted, and they're going to have to be cut off and discarded from this project anyway. And that just kind of shows you that, pattern welded steel, it's you do not end up with anywhere near the amount of steel that you start with. It's just how it is. Forging process, all the scale you're creating, removing material for creating the pattern, or just collateral stuff like this, you have to hold on to the end of the bar with something, and that doesn't get twisted. So that's just all part of making powder welded steel. So let's get the other two heated up and twisted, and we'll clean all these surfaces up.